All right, guys. Today we'll be talking about the lesson for day 6, measures of spread and the shape of data. So let's just jump right in. Measures of spread are values that describe how spread out a data set is. Two, the measures of spread are IQR, and this is a Q, and range, RANGE. Okay, and already we're going to stop right here. This, again, guys, IQR stands for interquartile range. Okay, let's forget about range for a second and just focus on this. I want you to pull out your compositional notebooks, and I want you all to write this out. Let's say median versus mean. If I have a data set, let's say video games played per month. How about that? And let's say January, I played 1 game. February 8, and we just keep going. 7, 15, and our final value would be, let's say we went crazy 1 month and we played 500 video games. Yeah. So when I ask you to take the mean of this, I have to take this 500 into account. But is this 500 representative of all the rest of your data? No, it's much larger. It's what's called an outlier, right? This is an outlier. And that would just be a value that basically doesn't resemble any of your other values, and it skews your results towards it. So what is the mean of all this data? So that's going to be 1 plus 8 plus 7 plus 15 plus 500 over 5, right? So the mean is roughly 531 over 5. So the mean is roughly 106.2. Okay, that's your mean. This number is not indicative, or is not the best. It doesn't give you the best idea of what most of your values look like, which is why we do things like take the median, right? So in this case, taking the mean is a little less effective, because the median will give us a better idea of what most of our values look like, because we, in essence, are taking the very middle value of all of our data, which is not affected by the outlier that we have here, right? So if I said find the median, right, that's much easier. You can say right here to, and let's say, okay, 7. I like to crawl my way in towards the middle. So 7 is our median. And you could agree that, oh, and excuse me, guys, this 8 and this 7, this is actually, I'm glad that I made this mistake. This, when you do work with your median, you want to make sure that this is in order. So always lay your data out in order. So luckily, nothing changes with my mean, because it's all the same. But order does matter when you're taking the very middle set of your data, right? So when you're grabbing your median, you want to make sure your numbers are in order. So 1, 7, 8, 15, and 500 would be correct. 1, 8, 7, 15, and 500 would give you the incorrect median. So the correct median in this case would be 8, not 7. So kind of glad I made that mistake there. So the median here is going to be 8. And this, as you can see, is more representative of what most of our data looks like. It does not take outliers into account. Therefore, it does not skew your results towards the outlier. Okay? And we could even go one step further, and we could write this out on a box and whisker plot. Okay, so 1, 7, 8, 15, and 500. How about that? Let's make 500 all the way down here. Yeah, 500. That's our upper extreme, and our lower extreme is 1. Okay, so if our lower extreme is 1, then we just we keep going. So I could say I could just real quick, I'll determine my upper and lower quartiles, because we know 8 is our median, and the scale's going to be a bit off down here, but don't worry about that. That's not important. So our lower quartile range is going to be 7 plus 1 divided by 2, because we have 2 numbers to the left of the median, right, which is 8. So now we have to take these 2 numbers, add them, and then divide by 2. So that way we get 4. So let's put a little 4 here, right down there. And then, let's see, this will be the beginning of our lower quartile range. And our upper quartile range would be 15 plus 500. So 515 divided by 2. Well, that's going to be 257.5. So the upper quartile range, I'll just kind of put, let's just imagine this is the 200s, right? And then I'll say 257. And 258 would go here. And this would be 257.5. That's the upper quartile range. All right. And we draw a box around the median, which is 8, as we know, which is down here. Our whiskers are going to cover the extremes, so 500 is our upper extreme. Our lower extreme is 1. Okay, I got all that from up here, this data set. Video games played per month. We went crazy. So, when I'm even looking for my median, when I'm looking at median versus mean, the interquartile range right here that we used this box and whisker plot to determine, the interquartile range, the IQR, determines the middle 50% of your data. Right? So if this is 25%, this is 25, 25, and 25, then this middle 50%, these middle 2 tiles, these 25 and 25 will give you your middle 50%. This is what most of your data is bound to look like, okay? It's not safe to say or assume that you're going to randomly play 500 video games again next month, because that is an extreme. That is an outlier, yes? Outlier. Okay? This is an outlier. So it's safer to assume that you'll perform within this box right here, because the interquartile range, which you're finding using the median of either side of the big median here, gives us a range of where the bulk of the data is. So the interquartile range is the middle 50% of the data. You can also say IQR equals most common values, excluding outliers. And that's all. That's all I want you guys to understand. This, in some ways, are more effective. Finding the median and the IQR can be more effective than finding the mean, or the sum of all these over the total number of data points that you have. The median and IQR can be more effective than the mean because the median is not taking into account outliers. The median is only taking into account your middle 50% of your data, or the most common data points. Okay, so back to the original lesson, and we'll just kind of zoom through this since I went on a tangent. So we learned how to find the interquartile range in previous lessons. Range is the value that describes the spread of the data. To find the range, find the difference between the largest value in the data set and the smallest. So let's say the difference, so we'll be subtracting between the largest value and the smallest value. Okay? So find the range and the interquartile range for each set of data. Okay? And if you guys want to pull this out again, I like to map all my data out. It just makes things easier. So I see 1 0, I see 1 1, I see 3 2s, I see 4 3s right here. I see 4 3s, 1 2 3 4. This will especially just make your median a lot easier to find. I see 3 4s, and I see 3 5s, and I see a 6, a 9, and an 11. Okay. Well, they're asking us to find the range and the interquartile range for each set of data. Okay. The range is going to be easy, right? We just learned up here that the range is calculated by finding the difference between the largest value and the smallest value. So let's find that first. Our range is going to equal 11 minus 0 because we have our largest value and our smallest. So our range is going to equal 11. So now we need to find the interquartile range. This we need to find by using the median. So I'm going to crawl my way towards the center. My 1 goes with my 9, my 2 goes with my 6, and so on and so forth. 3 5 3 4 3 4. Oh, look at that. I got 2 middle values. So my true median is somewhere in between these two. Well, what's 3 plus 4? That's 7. What's 7 divided by however many digits? 2. That would be 3.5. So our median is 3.5, right? So this isn't the big answer. Maybe circling that would have been a bit confusing. I'll put a star by the big answers. So we found our range, and our median is 3.5, but they're asking us to find the interquartile range, right? Interquartile range, we've got the range. We need the interquartile range. So we use the median to find that. The interquartile range is going to be, well, we need to find our lower quartile range and our upper quartile. Sorry, our lower quartile and our upper quartile. So let's see what that is. So among our, from 3 to 0 and from 4 to 11, what is our UQ and our LQ? What is our LQ, excuse me? And what is our UQ? Upper quartile, lower quartile, upper quartile. So we're gonna say, well, the middle set of this data would be, and I'll crawl my way in again, from the 3, 1 to 3, 2, 2 to 3, it's 2. Okay. And what is it over here? What's our upper? It's 5, right? So how do we find our interquartile range, or IQR? That's going to be equal to the upper quartile minus the lower quartile. So the IQR is equal to what? 5 minus 2, which is 3. And we found it. Range is 11, IQR is equal to 3. Okay? And this is just a different representation of what data you see over here. Oh, excuse me, I misread that. This is something different. This is quiz grades, and this is runs scored. So just pay attention to your labels there. And the numbers are totally different over here too. So over here I see 58, and we can put this away, but I see 58, I see 75, I see 76, I see 80, 83, 85, and 88. 83, 85, 88. I see 90, I see 94, I see 100. Right. Okay, and we already learned how to read these in a previous lesson. So I'm just going to find the range. So what's 100 minus 58? Yeah, that's 42. So our range is equal to 100 minus 58, which is equal to 42. So that's out of the way. What is our IQR? Well, for that, we need to find our median first. It looks like we won't have too much space, so I'll just let you guys work this out in your compositional notebooks if you want. But, right here, 94, and I see 76 corresponds to 90, 80 with 88, 83, 85. So we got two values, 83 plus 85. And one quick trick here, guys, we don't really have to determine what the median truly is. I know it's going to be somewhere in between 83 and 85. So this way, I can probably just kind of jump to the next step and find my lower quartile and upper quartile. So we know that this is going to be maybe somewhere around 84-ish. So I can include all of this and all of this inside of my calculations for the lower quartile and the upper quartile. So upper quartile, lower quartile is going to be the median on the left-hand side, and the upper quartile is going to be the median on the right-hand side. So I see 90 and 76, right? Because 90 is our middle number here. And if you guys want to write that out on the number line, that's probably best, but just for the sake of time, I'm just gonna 58, so yeah, 76, and it's 1, 2, 3, 4, 5, and the middle value would be 90. Yes, so our interquartile range is going to be 90 minus 76, which is 14. Okay, so moving on, we'll do the rest of this in class, I believe. Actually, no, this is actually important. The shape of the graph can give information about the data. These terms can describe the center, spread, and shape of the data distribution. Use the dot plot to illustrate the terms below. Okay. Clustered is a group of data points located close together. So that would mean that these data points are clustered. Okay. Outlier, a data point that is much smaller or much larger than most of the other values in a data set that causes a gap. We talked about outliers, guys. Remember the 500 in our video game example? This 11 in the run scored example is the exact same thing. It's an outlier. It causes a gap from here to here. and it's just not like the others, and it doesn't happen as often. So it's an outlier. 11 is our outlier. The peak is a high point in the graph, so that's easy. What's the peak in this graph? Well, it's 3 because it's the tallest value. This is our peak. So with that out of the way, let's move on to this final bit here. I want you guys to write these words up top. Symmetrical, skewed right, and skewed left. Okay, this is pretty self-explanatory. Data is a graph. When we're writing out these graphs, like making our box and whisker plots, or you see something with a layout akin to this, the data is symmetric. There are a few. Whenever you plot a box and whisker chart, or it looks like this would be more of a histogram. So whenever you see a box and whisker chart or histogram, and you're seeing that it's carrying on a certain shape, these are words we can use to determine said shape. So when a graph is symmetrical when the data is evenly distributed. Evenly distributed. Graph data is evenly distributed. Graph has about the same shape on either side of the middle, right? So either your histogram or your box and whisker plot, it's kind of even down the middle. It has the same shape. That's easy. Now, a graph is considered to be skewed right when there are fewer data points on the right. So it's like our outlier. It will look something similar to up here, or my example with the 500 video games. The outlier would be all the way over here. This would be like our 500, and that would skew our graph over to the right. So it'll, just remember this, it's symmetrical when it's the same on both sides. It's skewed to the right when there's a tail on the right side, and it's skewed to the left when there's a tail on the left side. So tail on the right side, skewed right. Tail on the left side, skewed left. So fewer data points on the left. And there you have it. So this would have a tail on the right. So this is skewed right. This would have a tail on the left, skewed left. Plenty of ways to visualize that.